Welcome back to Mathematics Lifeline. In today's video, I want to prove that the square root of 2 is an irrational number. So this is one of the very first proofs that you'll see in any kind of a higher level proofs class. And this is something that you need to know how to do when you do college math because this is really as simple as it's going to get. And a lot of people haven't been exposed to proofs. And the education system does not do a good job of preparing you for these types of problems because we don't do much of it in your standard K through 12 schooling. But this is usually how you're introduced to it, in just these simple proofs, very easy to understand once you actually know what you're doing. So I want to go ahead and give you an example of that. But before we do, we want to define some key terms. So we're working with irrational numbers. So we want to define what we mean by a rational number so we can prove that square root of 2 does not fit there. So a rational number, we're just going to call it R. So we have any rational number R can be expressed as A divided by B, so a fraction. Now it's important that A and B are both integers, which is what I'm saying right here. A and B are in the set of integers. We know that B cannot equal 0, and we know that the greatest common divisor of A and B needs to be equal to 1. And the reason that's the case is because we need to have these in simplest terms. If the greatest common divisor was anything other than 1, that means we could simplify it. And that's not what we want. We want these in simplest terms, meaning they share no common factors other than 1. So these are just the defining terms of a rational number. It's very important to note these because we will be using this in the proof. And the other thing I want to define is an even number. So any even number can be expressed as 2n as long as n is in the integers. So the same notation I'm using right here. N is in the set of integers. So any even number can be expressed that way. So now that we have this out of the way, we can go ahead and start on our proof. So the proof starts here. And we're going to prove this by contradiction. Now this is a method you will learn in your intro proof classes, but here's just a basic one. This is the first one you'll see probably. So what I'm writing here is assume by way of contradiction, that's what this means. BWOC is by way of contradiction, that the square root of 2 is rational. So you can probably see what I'm doing here. When we say by way of contradiction, we're saying that, well, we're going to prove that the opposite is not true to prove that what we're actually trying to prove is true. So we're basically assuming the opposite and showing that that doesn't work. So that's the goal here. We want to make this not make sense. That way we can prove that it is an irrational number. So if the square root of 2 is rational, we can write it as some a over b with this definition. A, b are in the integers, b is not equal to 0, and they are co-prime with each other. So if square root of 2 equals a over b, well, let's just go ahead and try to manipulate this. Let's try squaring both sides. So when we square both sides, we'll get 2 is equal to a squared over b squared. And so now let's just try multiplying both sides by b squared and solving for a. So let's multiply by b squared. We get a squared is equal to 2b squared. So now that we have a squared equals 2b squared, we see that a squared is an even number. And the reason is because we know that b is in the integers. So that means that b squared is also going to be an integer. We can't square an integer and get anything that's not an integer. So that means that if we set b squared equal to this n, we know that a squared is even. And since a squared is even, we can prove this, but we're not going to in this video. Since a squared is even, a is also even. So a can be written as 2n. A is an even number because a squared is even. This right here is crucial. This is the definition of an even number, but it's in a different form. But it's important to know that b squared is always going to be an integer as long as b starts out as an integer. So if we know that a is even, then we've proven that a is even. We can go ahead and just plug the definition back into this. So now we can say that the square root of 2 is equal to 2n over b, because a is equal to 2n. And we'll do the same thing, square both sides. 2 is equal to 2n squared over b squared. And we'll just do the same thing, multiply by b squared. So when we do that, we end up with 2n squared is equal to 2b squared. And then we can simplify this. So let's go down here. Now we have 4n squared is equal to 2b squared. And then we can divide both sides by 2. So that gives us 2n squared is equal to b squared. So now we have b squared in terms of 2 times a number. And we know that, just like in this scenario, is the definition of an even number. So since b squared is even, b must also be even. So that implies that b is equal to 2 times some other number, k, we'll call it. So b is even. So now we know that a and b are both even, and that is a contradiction. And here's why. If a and b are both even, then a over b is equal to 2n over 2k. But you can probably see the problem here. These 2's can be canceled out. And we know that for the definition of a rational number, we don't need to simplify any terms. They should already be in their most simple form. So if we have 2n over 2k, well, their greatest common divisor is at least going to be 2. So that tells us right away that this can't work. That means that the square root of 2 is not a rational number, because when we put it into its terms, in terms of definitions, it's going to have a common factor of at least 2. So we have a contradiction, which proves that the square root of 2 is irrational. And that is the process of proving by contradiction. It's very important to learn this. It's very crucial. You use it all the time in higher level math. But yeah, so this is just kind of an introduction to your first proof. We've completely finished it. So a lot of people will finish it with different things. People use a box. Some people write QED. You can do a smiley face if you want. You can do whatever you want to show that the proof is done, or not do anything at all. But we'll use one of these in our math to just say we're done, essentially. But now that we're done with this proof, you've kind of been exposed to your first higher level proof. And I just hope that this can help you. And this looks like a lot right now, but trust me, whenever you learn the process and whenever you do more examples, you'll see that this really isn't that hard, especially in comparison to some of the other stuff that we prove in mathematics. But yeah, I hope this helped you. I hope that you enjoyed this video. If you did, leave a like or a comment. Just let me know what you think. Let me know what you'd like to see in the future. But if you don't have anything, then I will see you in the next video. Thanks for watching.